This is Project 8 of Hacking with Swift. We're going to make another game, but it'll be the last game you make using UIKit. Every game after this one will be built using a whole new library called SpriteKit. So to make this last UIKit effort really count, we're going to make a super advanced user interface, well, more complicated at least, with lots of stuff going on. And I've got some bad news. It's another word game, but it's a really cool word game. You'll enjoy it a lot. For more information, please go to the website hackingwithswift.com. There you can find this as a book, a much more detailed, informative and helpful and slower paced book, quite frankly, as well as the entire series in book form. Please buy one to help support my work. Alternatively, you can buy the videos too in high resolution format. They look fantastic. Otherwise, you can get in touch with me on Twitter. I am @2straws. I'd love to try and help you out if I can. Just get in touch or follow me. If you have any questions, let's talk. The game we're going to make is based on the popular indie game 7 Little Words. This will be our first game exclusively targeting iPad, and you'll soon see why, because we're going to use a lot of space in our user interface. So go ahead and launch Xcode, and when it asks you what to do, choose Create New Project, and then choose Application, Single View Application, press Next, call it Project 8. Choose iPad for devices, language Swift, no data, fantastic. Press Next and save it somewhere useful. There we go. Now we are going to immediately make sure this thing is designed for landscape orientation only, because it will not work in portrait, or if it does work in portrait, it would require significant UI redesign. So just deselect portrait upside down and portrait like that. Choose an iPad. I'll choose, say, iPad 2. And I do recommend broadly you do choose iPad 2 rather than iPad Air, because iPad 2 is not Retina, therefore it runs much, much faster. So choose iPad 2 and go ahead and press play to fire up the simulator, get it running. And it's the same thing we had before with iPhone, just an iPad. It's bigger now, so you get a large white screen. Not particularly exciting. There we go. So what we're going to do now is build up our basic user interface, and it isn't basic at all, but I'm trying to urge you in here slowly. Actually, we're going to create 2 large UI labels, 1 small UI label, 1 large UI text field, 20 UI buttons that are big, and finally 2 small UI buttons. This is the most complicated UI in the entire series, so don't worry. Takes you a while to copy what I'm doing. Just pause the video, rewind, try again to get it right. But trust me, the end result is definitely worth it. This is going to look fantastic. And as well, this is not just a game. Again, I use these projects as a way to sort of squeeze knowledge into you. You're going to learn all about some fantastic new Swift techniques, including property observers, searching through arrays. You'll do modulo, you'll do array enumeration, ranges, and more. You'll learn all sorts of things in here. It's not just about making games. So let's start with the 20 big buttons. Go ahead and click on main.storyboard to launch the interface builder. And you'll see a very small amount of space. That is not enough to represent our interface here, which is rubbish, because obviously we need to try and draw our entire iPad interface. Now, before I said that this is great because it stops you thinking about, individual size iPhones and iPads. It's all very abstract and cool. It is cool, but right now we need all the space so we can draw things exactly right for our layout. And that's done by saying, actually, don't give me a fancy square thing, just give me an iPad landscape size screen. So go under here to the file inspector for your view controller, and then you want to disable this box here that says use size classes. Deselect that. It'll ask you what you want to keep, and we want to keep iPad. Now choose disable size classes, and you'll see, if I zoom out perhaps a little bit, zoom to 25%, 1 large iPad portrait size screen. We can flip it around to landscape by going to the view controller and saying orientation landscape. Fantastic, 1 landscape sized iPad screen. So we're going to place on that 20 UI buttons. So I'm going to make some more space on my screen so you can see what I'm doing. Let's go all the way to the edge now. Get rid of that left-hand pane, perhaps. Maybe shrink in that a little. Can't go smaller. Can that shrink a little bit on the left? There we go. So that's about as much as I can see. It's almost the entire layout. We're going to place 20 UI buttons. So we're going to have the object library, search a button. We're going to place 20 of these things. And we're going to place them in a grid that's 5 items across and 4 items down. So the top left button, this one here I'm going to place, needs to be at X 200, then Y 470, like that. So towards the end, towards the bottom, but on the left-hand edge, like that. And it needs to be 120 wide by 60 high, like that. That's our button. Now we're going to copy this button again and again and again, spacing out 130 points each time on the X. So what you can do is you can hold down Alt and drag the button to duplicate it, like that. And you'll see it copies it like that. So we can now place it across where we want it as a copy of the button. I'll place this one across there, and then keep on copying these things. And really, we want to space them nicely. So like I said, we want 130 apart on X, and then 60 apart on Y. So we have X 200 here for the very first one. The next one, this one here, needs to be 130 points across from that. Therefore, it needs to be 330, like that. And this thing needs to be 460, like that. And keep on going. So let's keep on going across and make that 590, and then another one like that, 720. So that kind of, in fact, exactly, all being well, aligns those in the middle. Those are our 5 across. And then going down the way, we want 4 rows, so select them all, and now Alt drag to copy it, like that. 1, 2, and then 3. And they're sort of more or less spaced right. We can fix them up just slightly. So let's see what that was. Y 470, so we're going to want this one to be 530, so it's off by 8, so we'll move this up by 8. 1, 2, 3, 4, 5, 6, 7, 8. Is that correct now? Great. Move these two up by 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the bottom we're up to 8 as well. 1, 2, 3, 4, 5, 6, 7, 8. That should create everything. Look at that. Absolutely beautiful across the way. Huge grid of buttons. Now, we have all our buttons placed roughly correctly. What we're going to do is just move them ever so slightly. I use those round numbers because they're easier to type in and easier to do basic maths with if it's been a while since you were at school. But select them all now, and we're going to move them to the left. So tap the left cursor key 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And you see that blue line appeared like that? That means they are now centered there on the line, which is fantastic. So they are now in exactly the right place. Moving on, we are going to go to the Attributes Inspector with the buttons all selected and give them all the same tag. So remember, tag helps identify things uniquely, but it doesn't have to be unique. All we care about is that these are a certain type of button. These will hold our letters. So for tag, I'll enter in 1001. 1001 is our tag. Any old number, it doesn't matter what it is, but it's a number that you know, which means you can find it later on. And also, while you're here, please look for the type and change system to be custom. It's a small change. In fact, it will actually look almost the same in the layout. Once you give it a different text color, let's make it blue again. But it stops a default built-in Apple animation when you change the text. The Apple animation can look quite ugly sometimes for system buttons. It's great sometimes, but in this app it looks terrible. So turning it off to be custom buttons will make things much, much nicer. We're also going to change the font size, so click this T button. We have right now system size 18, which is Helvetica Neue regular. You can go ahead and make that bigger. I suggest 36, nice and chunky like that. Look at that, beautiful big text now. And the way the game works is each one of these will hold either 2 letters or 3 letters. So the most space this text can occupy is the widest letter 3 times, which is W, 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 all in caps like that. So those now contain a pretty good representation of the worst case scenario. So you can see it fits really nicely on the screen. those are our letter buttons. Now create two more buttons. Like this, let's drag them on. Both of these things should be the same size, i.e. a width of 75 and a height of 44, like that. The first one should be at X, so across the way 425, and Y 390. The second one should be at X 525 and also Y 390, like that. Oops, that's the wrong, that's the height. I want Y. Dear me, what a mistake that was. Let's try that again, shall we? You're correct. Let's try that again. So the first button, come on, Dopey, you can do it. X 425, Y 390. Second one, there we go. X 525, Y 390. Boom, so they line up quite nicely. The first button, we're going to put some text in there that says submit, all in caps. And the second one we'll call clear. This is how users can submit their answers to the game while they're playing. You press submit to go ahead or clear to wipe it. That's all the buttons required to make this game work. We're now going to place a text field like this, drag it on there, and we're going to try and position it a bit nicer because by default it has this sort of stroke effect around it. If you look at the size of the thing, we can't change its height, which is useless because this rounded rectangle effect only applies to text fields, and when it has it on there, you can't change the height, so it's a fixed height and size. If we kill the border style so it's transparent, then we can go ahead and add our own custom height. So please do remove under the attributes inspector, remove the rounded rect thing here and go for borderless so you can see exactly how the thing looks. Once that's done, we're going to give it a size and an X and Y coordinate again. So the width should be 535 and height 80. So really big. Then for position, we'll use X 245 and Y 315. That's where it's going to be. And this will hold our player's answer. Now a text field, if you remember, is an editable label essentially. It shows some text, but users can tap and type things in. And we want them to use this thing instead, pressing the buttons here. We don't want to type. So why are we using a label? Why aren't we using a label? Why are we using a text field? And the answer is because text fields have this wonderful property called placeholder text. And it makes our life so much easier. We can write in here, tap letters to guess, and it'll be filled in grey text. And when text goes in there, it'll be black text and erase the placeholder. So it just gives users an idea of what to do. Labels haven't got that kind of functionality because it's not designed to be edited. In fact, we can make our thing act like a label by just saying enabled false. And now that users can no longer tap in there to type in text by hand, they have to use these buttons. We want to, if possible, make that font size a bit bigger. So let's make, what should we choose? I don't know, let's make it 36. How's that look? Yeah, that's not too bad. 44. Yeah, great. And to finish it off, we'll center it as well. So that's where the user will be able to type in the stuff as they are going by tapping our buttons. We also need to make some more labels, actual labels this time, as opposed to sort of fake looking labels. So please search for label down here. And we're going to create two labels. First is 400 wide. So go to the size inspector and enter 400 for width and 280 high, like that. For its position, I want X 255 and Y 20, like that. This is where we'll have our clues. So you can just write in there for now, for easy reference, clues. So what things the player should find. And for the other label, place it on the canvas. This one should be at X 605 and Y 20, like that. And this one as well should be 165 wide and 280 high. So they line up roughly. Clues are wider because there's more text in there. This thing, if you want to, you can make it say right aligned like that, so it aligns to the right. It's down to you for your own design purposes. Select both of them though, and make sure you choose lines and press down to get line 0, which means make these labels go over as many lines as required to make them fit correctly on the screen. That's our clues label and our answers label. I'll just put answers in here to make my life easier in remembering what's what. Answers. We'll do one more thing, which is a score label. So create one last label just over here. Then give it a width of 70 and a height of 40 with X 830 and Y 20. This definitely should have text alignment right. There we go. That is our score label, and we'll use that to show the user's current score. In fact, let's make it a bit bigger perhaps. There we go, look at that. Fine, great. Okay, that's our layout complete. Now, if you've played games like 7 Little Words before, you'll know exactly how the user plays this game. It should look familiar to you. If not, we're going to show in here 7 clues that spell words, and the words we tap by entering them in here and pressing submit or clear to start again. And over here will be a clue, another clue to begin with, saying how many letters are in each word. And when you get it right, it'll show the answers in there instead. So the idea is user spells out the word by pressing these buttons here, then presses submit. That's the name of the game. We do have to do some things before we leave here. It's not just about layout, of course, it's also about outlets and so on. So please go ahead and go to the assistant editor and let's create some outlets. So what we're going to do is we're going to create 4 outlets. One for the clues label. So I'll create that now, control drag from there to here and call this thing clues label. Good. One for the answers label, again, control drag, let go and call it answers label. Good. One for the score thing. So the score is their current answer so far. So please control drag from that. Control drag from that into here and call it current answer. And finally the score. So select that label, control drag over here and create something called, there we go, where are we? There we go, never mind, anyways, good. Call it score label. Done. That's our, it didn't like it. I didn't like that at all. Let's try that again. I must have misclicked by accident. Let's put it there, score label. Yeah, that's fine, I must click by accident. So that's created our 4 outlets. We also want to create 2 actions. One from submit and one from clear. So we'll do that now. Control drag from submit down here and call this thing submit tapped. Now watch out. See, I almost made my usual screw up mistake. I was going to leave it as an outlet and actually it should be an action. Good, much better. Connect that. Any object's fine. We're not going to actually use the UI button stuff. And clear again. Let's pop a line in here. Outlet. No action. That's why I screwed up. You see, it keeps reverting back to be out every time. Clear tapped. Boom. 2 methods: submit tapped, clear tapped, and 4 properties to handle our labels and our text field. That is it. That's the most complicated UIKit layout we've done so far, and indeed we'll do in the entire series. I know it's involved typing lots of numbers in by hand, but the interface is now yours. Look, you can go back to here and modify it all you want to make the perfect game for you. It's your control. That's just my suggested layout. You can go ahead and modify it to be as good as you want. From here on in, all the rest is coding and fun, so hopefully. So we'll get on to the rest of it. So the game is doing is asking players to spell 7 words from various letter groups. If you look in the files for this project, you will see our level here. It looks like this. So on the left, we have letter groups, HA, UNT, ED, 3 letter groups, one being HA, one being UNT, one being ED, and then a clue, ghost in residence. Oliver has 2 letter groups, OLI, then VER, has a Dickensian twist, T-key. And the idea is they'll see this clue as well as 6 letters, because it is 6 letters, and somewhere VER will be on here, and so will OLI. And it's their job to try and spell it. You might think, oh, that's really easy. It's not really easy. If you haven't got the answers, you'll have no chance. It is indeed quite hard. These are some clues I just put together very quickly. By all means, make up your own. As you can see, though, we're using the pipe symbol to separate the letter groups here. So HA, pipe, UNT, pipe, ED. And then between the clue and the answer is a colon and a space. So HA, pipe, UNT, pipe, ED, colon, space, answer. And this is an exact little file format we've put together here specifically for this game. And we're going to load that text up and configure the buttons to show a letter group. So this one here might show POR, this one here might be FA, this one here might be TW, this one here PRO, whatever. So we're going to need 3 arrays to handle all this stuff. 1 to store all the possible buttons. 1 to store the buttons that are currently being used to spell an answer by the user, and 1 for all the possible solutions. So these things here on the left, these answers here will have to be held somewhere as well. Further, we need 2 integers. We need 1 to hold the player's score, how they're doing so far. Obviously we start at 0, but we should increment it over during play. And 1 to hold the current level. So we need to add these 5 properties. So I'll go back to my text file, viewcontroller.swift. And beneath our 4 properties so far, let's declare 5 new ones. So first up, an array to hold all the possible letter buttons. So var letter buttons equals an array of UI buttons. Like that. Create it. Then an array of activated buttons, things that are currently being used by the player to spell something. And another array of UI buttons. Good. Then an array of the strings that are the solutions. So for example, haunted, leprosy, Twitter, Oliver, and so forth. So we'll say var solutions equals array of strings. Go and create it. And then a score and a level. So var score equals 0, var level equals 1. There we go. Now, you will notice we made 20 massive buttons and gave them no IB outlets. Because doing so is quite painful. There's a lot of control dragging here and there, and of course doing actions for all of them. It's very annoying. There is a solution for this, but it's not particularly brilliant. If I show you what it looks like, you can go to Assistant Editor, go for main storyboard, and you can drag from one of these buttons down to property, and you'll see it says insert outlet, done that before, action, done that before, or outlet collection. An outlet collection effectively makes an array of outlets inside one thing automatically. And that does work very well, but it's time consuming, and these videos are always long enough as they are, despite me talking extraordinarily quickly, without having to go ahead and create 20 connections to the outlet, then 20 button actions by hand. So we are going to take a simple shortcut. And this shortcut will deal with calling methods when buttons tapped as well, so it's actually quite an easy solution. And the solution, the shortcut, is this. We gave all our buttons the tag 1001, or whatever number you chose out of the top of your head. So what we can do is we can loop through all the views inside our view controller and say, hey, if you have the tag 1001, you're one of my letter buttons, add it to the array, and make it call letter tapped when you're tapped. This is really easy to do. So go to the regular editor, choose viewcontroller.swift, and inside view.load, we're going to write this. For subview in view.subviews, that's all the views inside this view controller. We can say if subview.tag equals 1001, then we know it's one of our buttons. So we're going to first typecast it as a button by saying let btn equals subview as UI button. Then we're going to add that to our array of letter buttons by saying letter buttons dot append btn. And now we're going to use a new method which lets us add a tap action to the buttons in code. So we've been doing it by control dragging actions already. This is an easier way in code. All you do is say btn.addTarget. It takes these 3 parameters: what to send the message to, what message to send, and when to send it. So for the target one itself, tell us something happened. Selector, very carefully, you want to type, quote, letter tapped, colon. The colon's important. Then quote. Then for control events, please do dot touch up inside. That's what we've been using for all our other actions so far as well. It just means when the button is tapped. So it's going to go through all the buttons, make sure they are our letter buttons, add it to the array, then call add target with the colon. Now the colon, what it means is call this method called letter tapped, but pass it one parameter. You can choose no parameters or one parameter. In fact, there are sometimes you do 4 parameters, but in this case it's just one. And that one parameter will be the button that was tapped. Sender, we've used it before. Who is sending the message? And by having that colon in there, it means we'll be told which button was tapped, which is fantastic. So we can then read off the button, what its title was and do something interesting with it. So we're going to now try and load the level, which means loading and parsing that text file I showed you. So from the project files, now please copy them both into your project. I'll just grab those two now along with the array shuffling, which we'll use shortly. Put them all into your project. You've used array shuffling a few times now, so there's nothing new there, but the level file is just the text required for level 1. I'm only giving you one, sorry, you'll do the rest yourself, I'm sure. We're going to write a new method called loadLevel that parses level1.txt in the same way we parsed the JSON in the last project. And it's going to prepare our level to be played. Now you're going to meet a few new things in here. Specifically, you're going to meet the enumerate function, which is a special way to loop over an array. This is like a for loop. In fact, we use it like a for loop, but it does two things. So a for loop, you could see we extract from here the subview in view subviews. So find a subview, put it in there, find another one, put it in there, and so on and so forth. We don't know what position this item is in this array, but with enumerate we do. It tells us the index and the object at the same time. It's very cool. You're also going to meet the count elements method, which is how you count how many letters are in a string. You also meet a new method called string by replacing occurrences of string, which lets you replace things on the fly. That's enough talking. Let's go ahead and do some coding. So go ahead and write below view.load func load level, then parentheses open brace. We fix that spacing just slightly. There we go. So to begin with, we want to have some holding variables we'll modify throughout the method. So if we want var clue string equals empty string, var solution string equals empty string, var letter bits equals an array of strings. So these two, this first one will hold the ultimate thing that's going to go into this label here. It gets built up as we parse the thing. And this solution string, that will hold what goes into here, the answers label. And this will hold the complete set of these things. So it will hold 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it will hold each of these things as letter groups, one per item. So we can assign them randomly to the buttons. So first up, we're going to use the path for resource method again. You've seen this before, to pull out where our level file is. It's called level1.txt. So we can say if let level file path equals nsbundle.mainbundle.path for resource, and it's called level. I'm going to use string interpolation here to pull in our level variable. So I'll do backslash parenthesis level parenthesis like that. Quote of type txt. If we have that file basically, then inside that we'll try and load it using if let level content equals. Now you already saw ns string contents of file, and you've seen ns data contents of URL. It's a very, very powerful way to pull things from disk quickly and easily and start doing things with it. So we're going to use that straight away. So here we want to say ns string contents of file, like that. Load this file from the disk. I've chosen the wrong one because I'm slow. ns string contents of file with used encoding. Remember, we don't want to specify the encoding. We want to be told what the encoding was. So contents of file is level file path. Use encoding nil, don't care. Error nil, don't care, because this will only execute correctly if that evaluates to be something. Because we've got if let, keep us safe. Then, if we pull out this array of stuff, which we have done, this has been loaded correctly, we want to split it up into lines. And that's where we use components separated by string again. So write var lines equals level contents dot components separated by string. So components by string, that's it there. Again, use code completion, otherwise you'll be here a very long time typing things out. It'll do your head in. Please don't do that. This code is basically identical to the word scramble game we made in our previous game, so it should not be any way surprising. Split it by \n again, so to the new line character, as it were. So we've got now have an array of items we can use. What we're going to do is shuffle up the questions or the clue. So we've got this. That's an item. That's an item. Item. We'll call lines.shuffle to randomize the order of the clues, so we don't know what order they're coming in now. And now we'll do the interesting stuff. We're going to use the enumerate function to pull apart the lines. So count from 0, 1, 2, 3, 4, 5, 6 to the end, and pull out the item at the same time. So the old style loop would have written would be something like this: for line in lines, do stuff. And that works okay normally. But in our case, we want to actually have the position of the line inside the array in our user interface. And this will become clear in just a moment, so bear with me. Change this code to be for parenthesis index comma line parenthesis in enumerate lines. Now we must typecast this. Remember, this thing here returns unhelpfully an array of any object, and we need to typecast it as an array of strings like that. That will enumerate through everything in there, pulling out each line as we go. So we now have that line and index 0. What do we want to do with it? Well, we know that on the left hand side, everything before comma space is the answer, everything after that is the clue. So we'll call components separated by string again. We're going to say let parts equals line dot components separated by string, quote, comma space, like that. So that'll return 2 items. Everything up to here, then everything from here onwards, like that. For each thing, we'll have 2 parts. So we now know on the left is the answer. So we can say let answer equals part 0 and let clue equals parts 1. So that's the left and right hand side of our split level line. And this is where index becomes useful, because our clue string, this thing here, that's going to be set inside that large left hand label, we want it to show the number of the clue, just so users can see the 7 every time, and the clue itself. This will use string interpolation in a slightly smarter way, as you'll see. So we're going to write here clue string plus equals, I add this and assign it back to clue string, quote, backslash parenthesis, index plus 1 parenthesis. So this is string interpolation here. That's putting that variable index, which will be 0 at first from this enumerate loop here. It'll be from 0 to 6. It adds 1 to it, so it counts from 1 to 7, which is a more natural way for consumers to count. So you can see we can actually do basic operations in here as well. It's not just a matter of putting variables straight in there. You can put code in there as well. So that adds 1 to index. Then we'll put a full stop after it in the string and put the clue. So backslash parenthesis clue parenthesis like that. Add a line break. Brilliant. So that will now say 1 dot ghosts and reticence, 2 dot a biblical skin disease, 3 dot short but sweet online shopping, and so forth. So it makes it look a bit nicer in the user interface. And now it's time to handle the solution. So our solutions right now have these pipe symbols in between them. And we want to know what the actual text is. We can match it against when users type HAUNTED, we can spot it means haunted. So to do that, we want to convert the left hand, part 0, which contains HA pipe UNT pipe ED. We'll convert that to be the word haunted. And that's easy enough to do by using string by replacing occurrences of string. It's a long thing, but again, super descriptive method names from Apple. We can say let solution word equals answer dot string by replacing occurrences of string. This takes various options. Fortunately, they're all optional apart from the first two, so we just have to provide the first two. We want to replace pipe symbol with nothing at all and ignore the rest. Forget the rest. Just do the default behavior. So wherever you find a pipe, just take it out and replace it with blank. That gives us a solution word. And we can now add that to our array. We can say, well, solutions dot append solution word, like that. So it'll go into the array as one of the viable solutions. We're then going to put that into the solution string thing, which we're declaring here, in the same way we're doing it here for the clue string. This is the matching thing. And this is where we're going to use the count elements function call. So we're going to do solution string plus equals, i.e. assign and add, quote, backslash parenthesis, count elements, solution word, then end parenthesis twice, then letters. And that will add the length of this word for the word letters. So it'll say, in this case, we have, what's the first one? Haunted. It will say 7 letters. Next one, leprosy. It will also say 7 letters. But it gives them a clue what kind of length of word to find. The final thing to do is to construct our letter bits array. That is a full collection of all these things, HA, PRO, OLI, ZAB, POR, whatever. A full array of all of those 20 items. And that's done by, again, splitting up with components separated by string. This method is just so popular. I'm going to say let bits equals answer dot components separated by string. In this case, it's pipe. And then add that to our letter bits array. Letter bits plus equals bits, like that. So that is stacks of code. There's more to do in just a second. But just temporarily, I'm going to put in a little comment here saying, now configure the buttons and labels. There's more work to do. And if you've read all that code first time and thought, wow, this all makes perfect sense to me, well done. You can just fast forward the next minute or two when I explain what it does. But quite a few of you, I expect, won't understand what it's doing, and that's fine. I'll whiz over it now. So first you've seen, I'll hide this to make more space. First you've seen path resource already. Used in our last game, in fact, that finds the exact file system location of the level 1 txt file. That will interpolate to be 1 at runtime when it's being run back, and so level 1 txt will be found. If it finds that, i.e. if it finds that thing successfully, it will try and load it using NSString's contents of file. This is just like NSData's contents of URL we used in our little web browser project in the last project. So it then loads the level contents up. It then splits it up by \n, i.e. line break, into an array of lines and shuffles it so it's different every time. It then loops through the array using the enumerate function. And this is important because it gives us an index, i.e. the position of the line inside the array, as well as the line as we go. And there are times like now when you really want that, so we can put numbers, positions into our clue string. For the parts inside each line, we split by colon space. On the left is our answer, this bit. On our right is the clue. We then add that to the clue string using string interpolation with a little bit of maths in here. And then to get the solution word, we take the current answer, remove its pipe symbols, and add that to the solutions array. And finally, for the solutions, we add in to its solution string the number of letters defined for each answer. Then add the bits of the answer into our letter bits array. That's what it's doing. Lots of splitting and joining, all that kind of thing. There is one thing you're thinking, wait a minute, this isn't quite right here. because you might remember back to project 5 where I told you about the word is real method. And there we'd used NSString, and I said, well, hey, it's okay because we can use NSString here rather than Swift strings, because NSStrings are 100% compatible with Swift strings. And what we did in that method was use a length property. We said something like, word NSString equals meh. I better put in var before that, otherwise I get confused. And then we said word.length, like that, to find the length of the string. Here, we're using count elements and not .length, because NSStrings have a length property, whereas Swift strings do not. They are not 100% compatible. They're sort of 99.9% compatible, perhaps. And this might seem annoying because you want to read the length of a string. Why is it not as a length property we can call rather than using a separate thing? It is an epic corner case. But NSString is an extremely awesome way of handling strings and has been for years. It handles everything from traditional Chinese to obscure dialects of languages. Thai script, all Indian varieties are all working fine inside NSString. But there are some cases where NSString falls down. And Swift eliminates the corner cases. There's one particular example, for example, which is a emoji. Emoji are they're hideous hacks, but they're behind the scenes. They are complicated characters which are not pictures, which the system recognizes to mean this is a cat smiling picture or something like that. To be honest with you, NSString has been used in about 1 million apps so far in the App Store, and it seems to work just fine. So it really isn't a problem, but Swift does eliminate it once and for all. It does measure emoji correctly at the expense of some performance. Count elements is slower. It literally iterates over the letters, saying 1, 2, 3, 4, 5, 10. But it's always correct, whereas NSString in some obscure corner cases can be incorrect. Enough tedious stuff. All you care about is count elements, is the Swift way of measuring the length of a Swift string. Time for some more code. Our current load level method ends with this comment here saying, now configure the buttons and labels. If only it were that easy. We need to modify this to fill in the final part of the method, specifically setting that clues label and answers label with the right text, shuffle up the buttons and letter groups, and then assign letter groups or letter bits to buttons. Before I show you the actual code, there is a new string method to introduce, another one. And this one, again, is wonderfully self-descriptive and long. It is string by trimming characters in set. And it removes any letters you specify from the start and end of a string. And usually with this method, the letters you specify are white space and new line character set, which means spaces, tabs, line breaks, and so on will be trimmed off the edge correctly. And we need exactly that code here. So what we're going to do is we're going to say with this label, clues label dot text equals clue string, we've been building up over time here, dot string by trimming characters in set, dot white space and new line character set. Like that. To be fair, that's a lot of typing. You might find it easier to do something like string by trimming characters in set, ns character set dot white space new line, like that. So it kind of co-completes for you. Like I said, if you just use straight dot rather than specifying the actual type, it does not code complete currently in Xcode, which is quite annoying, as you can see. So in this case, you may want to type out the full thing. So that sets the clues label, which does the same thing for the answers label. So answers label dot text equals answers. What would we call that thing? Oh, a solution string. Of course, solution string. Dot string by trimming characters in set, ns character set, dot white space and new line character set. Fantastic. Look at that. That'll set the two labels correctly. And now we want to whiz through all the letter bits, H, A, U, N, T, E, D, and so forth, and through all our buttons and assign them randomly to different bits. So we'll do that by first shuffling both of them, i.e. letter bits dot shuffle, and then letter buttons.shuffle. So both are in a random order now. And just to make sure, we're going to say if letter bits.count equals letter buttons.count, we'll do stuff. Now, to be fair, this always should be the case. If you've designed your level correctly, there should be 20 letter bits because there are 20 letter buttons. But this at least stops it going crazy if you do make a level incorrectly. So this time we're going to loop through every letter bit and assign it randomly to a letter button. The easiest way to do that is to use a new kind of loop you haven't seen before. It uses a range. And what we're going to do is we're going to say for I in 0 ... less than letter bits dot count. Now less than is what Swift calls the half open range operator, and it calls it that because it counts from 0 up to a number, but not including that number. It does not include the upper limit. So our letter bits.count should be 20. Of course, our arrays count from 0, so we want to count from 0 to 19, which is ... less than. If you want 0 to 20, you would do ... which means from 0 to, in this case, 20. For now, we want ... less than, which means it will count from 0 up to 19. And we're doing it this way because this array has values from 0 to 19. So does that array, which makes it really simple to set button titles. We can go in here and say for this value, letter buttons I dot set title, which modifies the title text of the button, to be letter bits I for control state dot normal. So assign 0 letter bit to 0 letter button, 1 letter bit to 1 letter button, 2, 2, 3, 3, or 19, 19. And it'll be different every time because the letter bits and letter buttons are being shuffled every single time. So we can be guaranteed it all works correctly. Go ahead and press play now and just make sure it's actually working correctly. We should see absolutely nothing. And the reason for that is schoolboy error. This is a brilliant load level method. Really, really cool. Does tons of stuff, but it's not actually called anywhere. We're not calling load level, which means it's not going to do anything. So to fix that, we have to call load level from inside view.did_load. So go ahead and make some space beneath this for subview in view subview's loop, and just write load level parentheses like that. And then press run now, and hopefully, let's see, fantastic. So you can see it's done an awful lot of work in that load level call. It's given all our letter types across here. It's randomized the order. It's put the correct text 1 to 7 and the number of letters here. Of course, you can't do anything yet. In fact, if you do anything, it just crashes. These two don't do anything, but this one will just die because we haven't made the letter tap method yet. That's fine. But we're getting there. That's not bad going, I think, for one method. So we're going to add 3 more methods now that make the game actually work. And in fact, these ones finish the game pretty much completely. Starting off with the most important one, which is letter tapped. This is done using, if you remember, add target. It'll call letter tapped and pass it as a parameter to the button that was tapped. So we'll create a new method. So we'll look in here, func letter tapped. And the button is a UI button. That's a sender. So what we're going to do is quite simple. We're going to say add the text of the button's title to our current answer, and then put that button inside our activated buttons array. That's up here, this thing. And finally, make the button hidden. This stops players from tapping it again and again and again and basically cheating or getting confused. So we're going to say in letter tapped, current answer dot text equals current answer dot text plus btn dot title labels, title label force unwrap dot text force unwrap. So add the text of the title of the button to our current answer and put it back into the current answer. We then use activated buttons dot append btn, and finally a new property btn dot hidden equals true. Make this button hidden now. So 3 things: get a text from the title label and put it into the array, into the current text, then add it to a list of buttons that are currently being used to answer the question, and then make the button hidden so it can't be used again. Now, this activated buttons array is actually quite important because we want to, when the user presses clear, we want to obviously show all the things that are currently hidden as a result of the user playing with them. So in the clear tapped method down here, let's do that now. This should firstly clear the current answer box, so current answer.text equals quote quote empty, no more current answer. Then we want to loop through all the buttons inside our activated buttons array. So do for btn in activated buttons, and we're going to do btn.hidden equals false, no longer hidden, it's been tapped on clear. And finally, let's remove the array of stuff, so activated buttons dot remove all, like that. You don't need to keep the capacity, it doesn't really matter, you can just do that entirely if you want to. There we go. So zap the current answer, re-show all the buttons that we're playing with right now, and then remove the all the items from the activated buttons array. And actually, that's kind of already working. You can go ahead and run the app now and see what it does. You should be able to see. I can do eth pour ha pro clear, and back they come. So the game's coming together quite nicely. Let's now have a look at submit tapped. This is more challenging. This has some actual work to do. We're going to have to use a new function here called find, which searches through an array for an item we specify, and if it finds it, tells us its position in the array, which is very helpful. It does return optional, as it might not have found anything, so we must unwrap its value very carefully. So if the user gets an answer correct, we want to change this thing so it stops saying 7 letters and now says leprosy, so you can see at a glance the one they have correct. The way we're going to do this is so simple. First, find will tell us which solution matched their word. We'll literally put their word in against this solutions array and find where it exists. And if it does exist, fantastic, it's a real answer. All we have to do is split the text up of this label by new lines, by line breaks, because we're using line breaks down here to load them. So here we go, line break there and line break here. So we can split up by line break to get a new array of stuff. We can then replace it dynamically with the answer and rejoin it again. There's a new method you haven't seen yet called join, which puts things together again. So it splits it, changes the one that got correct, and rejoins it. Once that's done, we want to clear the current answer text field and add 1 to the score, so the user can keep track of how well they're doing. And if the score is evenly divisible by 7, we know they've found all 7 words. So we need to show a new UI alert controller that will prompt the user to go to the next level. Now the evenly divisible task is done very easily with most languages, including Swift, using modulo, which is a way of saying how many times this number A divided into number B wholly, and what is the remainder, C. For example, you would say that 3 goes into 10 3 times, because it makes 9, with a remainder of 1. Therefore, 10 modulo 3 is 1. It's like the remainder operation. 11 modulo 3 must be 2. And 12 modulo 3 is 0, i.e. 12 divides perfectly into 3 with no remainder. If score modulo 7 is 0, it means we know they've answered all 7 words correctly. And that is all you have to know to make our submit tapped method. So scroll down and add this code to submit tapped. First off, let's optionally find whether the solution they've entered exists inside our array. So we can do if let solution position equals find solutions, search here. What we want to search for, let's do current answer dot text, like that. Oops, that's a open brace. So if it has been found in the solutions, the current solution, if it is contained in the list of actual solutions for this level, then we want to remove everything from the activated buttons array. Get rid of all of it. We don't need it anymore. These buttons are dead. Next up, we want to try and split this label by new lines. So we can replace the appropriate one. So to do that, we're going to say var split clues equals answers label.text force unwrap dot components separated by string. In our case, line break again. Then we want to modify the answer. So where it did say 7 letters, it should now say haunted. And that's so easy to do. We're just going to go ahead and say split clues solution position, which we got back from the find function here, equals current answer.text. That's it. So find the item at that position and replace it with the current item. Clear the current item. Oops. Current answer.text is empty. Good. Add 1 to score. Excellent. And then if score modulo 7 is 0, let's start now. So if score modulo is %, if score modulo 7 is equal to 0, then we have answered all the questions correctly. So we'll show an alert controller. Let AC equals UI alert controller. We need to give it a title in our case, something like well done. A message, are you ready for the next level? Question mark. And prefer to start as alert. We're going to add an action, so we'll say ac.add action, UI alert action. Title is let's go. Style is default. Handler is level up. That's not written yet, by the way, don't worry about it. And finally, we'll call present view controller. AC, present view controller, AC, animated true, completion false. So that sets up our you win message. To go to the next level. The actual method for this is quite straightforward. We'll go to here and say func level up. Remember, this is clicked on as part of a UI alert action, so we must accept the UI alert action. So action, UI alert action, like that. They're going to the next level, so let's add 1 to the level array. Of course, we only have 1 right now, so this is going to work terribly well. Then call load level again. In which case, it'll use string interpolation to find level 2.txt, which does not exist yet. This will crash, and use that instead. We also need to show all the buttons that have been used as part of the game. So we'll say for btn in letter buttons, btn.hidden is false. And that's it. Now, your job, of course, is to go ahead and create level 2.txt, level 3.txt, and so on. That is totally down to you. I've given you the code. You can do the rest of the legwork. Please make sure that obviously you must have 20 letter groups per level, otherwise it will not be very happy. There's one thing we're going to do before this project's finished, and it's really small, and we'll do it in seconds, and you've seen it briefly already, to be fair, all the way back in project 1. It's called property observers. So right now we have a property called score that's set to 0 when the game's created, and it increments by 1 whenever an answer is found. But we don't do anything interesting with that score. Our label is never actually updated. The solution to this problem is to use string interpolation. You might say something like, score label dot text equals score, score, like that. And that will take the current score value and put it into the label. We can even put that in here, and it even works. That's kind of okay. Not brilliant, kind of okay. Let's try it out actually. Let's see how it looks. It's whinging. It's whinging. And I am wondering why it's whinging. Because I'm being silly. Sorry. This thing should be nil, not false. It's a bad pull. Sorry. Let's run this back again with our slight score change. We can say, what is the hipster heartland? The answer is portal, and submit. Score's gone up. This hasn't changed. We've got a slight bug in our code. What did I get wrong? Oh, a silly thing. See, I'm making tons of errors. That'll teach me to record stuff late at night. Very sorry. We replace the split clues thing with the right answer here, but we don't put it back into the answer label. That'll teach me. I've made so many mistakes in this project. You're so patient. Thank you so much. So once we split by new line, we replace at the right position using the text the user entered. We then use answers label dot text equals join new line split clues, like that. That will cure it. Let's have a look. The zoological web is Safari submit. Perfect. Look at that, all working very nicely. Ghosts in residence is haunted. Submit. Perfect. Very nice. And see how score's changing as we go. You could do it that way. You could put, literally score label equals that wherever you modify the score. But this has a problem, of course, that if you modify the score in more than one place, you have to copy and paste that code everywhere, which is not very pleasant. So we'll use a property observer, as you saw in project 1. We can modify this to say var score, it's an integer, so int, starts at 0, and we're going to say when it's set, we're using did set, then update the label. And that's what it takes to add a property observer. You should see we had to clarify the data type of a variable when making a property, when adding a property observer. Otherwise Swift will complain. See, there we go, complain. Bad, make sure you declare it's an int. Otherwise, anytime the score variable is changed by anyone ever, that did set will be called and the score label will be changed. And that ends our project. It was, I think, apart from the UI layout and the grid perhaps quite complicated. It was mostly simple. And at the same time as learning lots of great stuff like add target, enumerate, count elements, find, join, replacing occurrences of string, property observers, range operators, and a subtle difference between Swift strings and NS string, you've also got a new game, which is fantastic. Another project under your belt, which you can go and customize, ship, do what you want with. It's your code now to go ahead and make stuff with. Have fun. And don't forget, for more information, go to the website, hackingwithswift.com. You can buy this whole project as a book, an ebook. It just costs, I think, $3 or something really crazy cheap. Or you can buy the whole series of books at a great discount. You can also buy the videos for this in high resolution to watch back at a slightly nicer, leisurely way. And you can follow me on Twitter. I am at 2straws. By all means, come and say hello. I do love to hear from my adoring fans. But if you're a hater, please talk to someone else. Have fun with the game. Good luck.